This is an interesting problem. In the solution of this problem, we are going to use three fundamental theorems of geometry. So stay with me to see all three theorems. So the problem is quadrilateral with the sides AC is equal to 10, AB is equal to 6, and these two 90-degree angles, and AD is equal to DC. We are looking for BD, the red segment. How do we find the length of red segment? So let's start with the triangle ABC, which is a right triangle, and we can use Pythagorean theorem, which is the first theorem that we are going to use in this solution. So since B is a right angle, we can write the following equation: x squared plus 6 squared is 10 squared, which is the Pythagorean theorem. If you solve this equation, x squared will be 64 and x is 8. So now we know the length of BC. Again, using the same Pythagorean theorem, we can solve the triangle ADC as well. So two sides of ADC are equal, x, and the hypotenuse is 10. So that gives us x squared plus x squared is 10 squared. 2x squared is 100, x squared is 50, so x is 5 root of 2. Now we know the lengths of AD and DC. So basically we know all the lengths in this figure except BD. To find BD, we need a theorem. So this is going to be second theorem in this solution. So the theorem is Ptolemy's theorem. Here is the guy's picture. It's a really old one, and it's a fundamental theorem in geometry. The theorem is when you are given a quadrilateral inscribed inside the circle with the lengths ABCD and two diagonals with the lengths of E and F. The product of EF is equal to AC plus BD. So this is Ptolemy's theorem. We want to use this theorem in the solution of our problem. However, in our figure we don't have a circle. So where is the circle? This is going to be our third idea in this problem. When you have two right angles extending the same segment AC, like in this picture, you can always draw a circle around that quadrilateral ABCD. So that's the third idea for today. Since we have a circle and quadrilateral inscribed inside the circle, we can use Ptolemy's theorem, and using that theorem, the product of two diagonals, 8 times 5 root of 2, is going to be the product of opposite sides, 6 times 5 root of 2, plus 10 times x. Solving the last equation, 40 root of 2 is equal to 30 root of 2 plus 10x. 10 root of 2 is 10x, and x will be root of 2.